In this video tutorial, we're going to be reviewing how to FOIL, factor, and complete the square in preparation for our upcoming test. Let's take a look at question number 1, where it wants us to multiply the following, 7n plus 2. And what I know is that whenever we see a binomial or a polynomial raised to the second power, that means we're going to be multiplying it by itself. So what exactly is that going to look like? Open parentheses, 7n plus 2, close parentheses, open again, and we're going to be writing the same thing, 7n plus 2, great. So now we're going to need to multiply by foiling, and we remember that means first outer, and then inner, last, great. So what exactly does that look like? Well, I know that 7n times 7n is going to give us 49n squared, and then 7n times 2 is going to give us 14n, and then again we're going to have to do at the bottom, 2 times 7n is going to give us once more 14n, and then finally 2 times 2 is going to give us positive 4. Great. We're going to have to do a little bit of combining like terms, and I know that we can combine 14n and 14n, and so the answer is going to be 49n squared plus 28n plus 4. And that's it, ladies and gentlemen. Let's take a look at question B. It's 2n minus 7 squared, so we're going to be multiplying it by itself. And again, we're going to be foiling 2n times 2n is going to give us 4n squared. 2n times negative 7 is going to give us negative 14n. And then likewise, negative 7 times positive 2n is going to give us negative 14n. And then finally, negative 7 times negative 7 is what? Well, I know a negative times a negative is always a positive. So again, that's going to give us, this time, positive 49. We've got to do a little combining of like terms, and I know that we can combine 14n and 14n. So what is this answer simplified? 4n squared minus 28n plus 49. And that is our answer. Let's FOIL question C. We're going to do 7n times 7n is going to give us 49n squared. 7n times negative 2 is going to give us negative 14n. And now we've got positive 2 times positive 7n. It's going to give us positive 14n. And finally, 2 times negative 2 is going to give us negative 4. Great. And what I know is that, again, we're going to be combining like terms. Negative 14n plus 14n, it cancels out. So all that we're left with is simply 49n squared minus 4. This is our answer. For question D, we're going to be multiplying negative 8, a to the second, b to the third, into this first term, the second, and then the third. And what I know is that when we're multiplying variables, we're going to be adding the exponents. So what exactly does that look like? So let's say we're just looking at this, this first set. I know that negative 8 times negative 3 is going to give us what? Positive 24. But what about the variables? So I see we've got a to the second, and then we've got a single a right here, and there's a little invisible 1 right there, but I'm going to make it visible, and I'm going to do the same for this b. And what I know now is that a to the second times a to the first is going to be simply a to the third. Likewise, b to the third times b to the first is going to be b to the fourth. Again, we're going to be adding the exponents when we're multiplying. I know that's a little bit confusing, but that's how we roll. All right, negative 8 times positive 4 is going to be what? Negative 32, right? And then a to the second times a to the first is going to be a to the third. And then b to the third times b to the second is going to be b to the fifth. And then finally, negative 8 times negative 1 is going to give us positive 8. And then we're simply going to carry over these variables. So it's going to be positive 8, a to the second, b to the third. And then we need to pause for a second, and we need to think, can we combine any like terms? No, I'm looking at the variables, and there are no like terms in this instance. So this is our answer. Question number 3 wants us to solve, and I see it's 2x plus 3 squared equals 25. How do we approach this? We're going to need to apply the square root to both sides, and when we do, we're left with simply 2x plus 3 on the left side, right, because this cancels out, and 25 is a perfect square, so it reduces to simply plus minus 5. Great. So now what we need to do is we need to get x by itself. So let's apply the inverse operation, and we're going to subtract 3 from both sides. And I know that, let's start with the positive. All right, so it's going to be 2x equals positive 5 minus 3 is going to give us positive 2. And then we're going to apply the inverse operation one more time. And I know that 2 divided by 2 cancels out, so we're left with simply x equals 1. Great. And so that's our first root. We're finding roots, right? But I also know that because we reduced the perfect square 25 to plus minus 5, we've got to figure out what the other root is, and I can see that it's also minus 5. So let's write that like 2x equals, and if we subtract 3 from both sides, it's going to be minus 3 minus 5. And I know that negative 3 minus 5 is going to give us negative 8. And so 2x sure does equal negative 8, and we've got to divide both sides by 2. And when we do, x equals negative 4. Great, so we've got our first root and our second root. For question number 4, we're going to need to factor, so let's find the GCF. And we'll start with looking at just the coefficients, and I see negative 20, 24, and 32. And I know that 2 goes into, right, negative 20, 24, and 32, but I don't think that's the GCF. I don't think that's the greatest common factor. I know that 4 goes into all 3 terms, so I'm going to factor out a 4. And now what we need to start to do is look at the variables. So I see we have a to the second, a to the third, and then here we have a to the first. So at most, what do they have in common? A single a, right? And when we take a look at the b variable, I see they have b to the third, b to the second, b to the second. At most in common, they have a b to the second. So let's factor out a b to the second. And what does that leave us with? Well, I know we're going to have to do open parentheses. And negative 4 times what gives us, positive 4 times what gives us negative 20. I know that it's going to be a negative 5. And how many a's are sort of left over? A times what gives us a to the second? We've got a single a. And then here we're at b to the third, and we can multiply simply b to the second times b will give us b to the third. Great. So now we got to factor out this second term. So 4 goes into 24 how many times? 4 times what gives us 24? So it's going to be positive 6. And then here I see we've got a single a, right? So a times what gives us a to the third? A times a to the second gives us a to the third. And I know that the b's have already been factored out, so we're all done there. Great. Now let's take a look at this. 4 times what gives us 32? Positive 32. It's going to be 8. Great. And here I see this is a to the first. So we've already factored out this a. So there's going to be no a in this term, nor is there going to be a b. And so we just wrapped up factoring this expression. Tremendous. We're money. We're good to go. So we've got a factoring question, 4b, and I see that we've got a difference of perfect squares. How do we approach that? We're going to set this up like we normally do with 2 sets of parentheses. And because 25, as I said a moment ago, is a perfect square, as is m to the fourth, because the exponents are even, we can break that into, or we can factor that into 5m squared times 5m squared, right? And what about 49? I know that what times what gives us 49? Simply 7, and then we see it's n to the fourth, so we can do n to the second, 7, n to the second, but we can't forget the signs critically, because this is a difference of perfect squares. We're going to have a positive in the first set and a negative in the second, and so we just factored that, and if actually we FOILed this, that would simplify to 25m to the fourth minus 49n to the squared, n to the fourth, and this is, ladies and gentlemen, our answer. Again, we'll be factoring for question 4c, and I notice that it's a to the second minus 6a plus 9. How do we approach this? We got to figure out which pair of numbers multiply to 9 and add to negative 6. And so what numbers multiply to 9? if we're not even worried about signs right now, right? Well, 9 times 1 is that pair works, as does 3 and 3. And do either of these combinations add to negative 6a? Yeah, well, if we have negative 3 and negative 3, negative 3 plus negative 3 gives us negative 6. Yeah, that's the combination that we're going to want to work with. So we're going to write this as we always do. And I know that it's a times a in the first set of parentheses. And we have minus 3 minus 3. And we could actually simplify that further to a minus 3 squared. So this, ladies and gentlemen, this is our answer. This is it factored. Let's factor in question 4D, where we have h to the second plus 10h plus 25. And we got to figure out which two numbers multiply to 25 and add to 10. That's pretty simple, right? I know that it's going to be open parentheses, close parentheses, open parentheses, close parentheses, h, and what two numbers multiply to give us 25? 5 and 5, right? And because 10 is positive, then that means that this is going to be h plus 5 times h plus 5. And we could simplify this further to h plus 5 squared. Boom. We're done. For question number 5, we're going to have to solve by factoring, meaning that we're going to have to figure out what these roots are, right? And to do that, we're going to have to get everything on the same side. And we'll start by subtracting 36 from both sides. And when we do, we're going to have x squared minus 9x minus 36 equals 0. Great. And so now here's the part where it can get a little bit tricky. We're going to have to figure out which pair of numbers multiply to negative 36 and add to negative 9. So I know that when we're thinking about 36, right? I know that it can be, 36. I know that 1 and 36 work. I know that 2 and 18 multiply together to give us 36. 3 and 12 and 4 and 9. Great. And so without even thinking about the signs, do any of these pair of numbers, when added or subtracted, give us negative 9? Well, clearly not 1 and 36. What about 2 and 8? No, because this could give us either 16 or 20, right? So that doesn't work at all. What about 3 and 12? Ooh, actually that might work. What about 4 and 9? No, because that's going to give us either 13 or 5. So maybe some combination of 3 and 12. So let's think about this. If this has got to be a negative number, right, and we're multiplying, it's got to be a negative, it's got to be a positive and negative. And this is a negative number, this is a negative 9. Thinking about that, that must mean that this has got to be negative 12 and positive 3. Great. So this is going to be open parentheses, open, close. And I know that we're always writing it like x times x. So it's going to be x plus 3, and then x minus 12. And again, this is equal to 0. And so we're not done yet. Some of you guys have had some confusion with these rapid assessments. 3 is not the root of x. So what we need to do is actually isolate x. So we'll subtract 3 from both sides. And so the first root is x equals negative 3. And the second root, likewise, x minus 12 equals 0. X equals positive 12. So that, ladies and gentlemen, is our answer. X is negative 3 and x is positive 12. Question number 6, we're going to be solving for the roots by factoring. And I notice that it's set to y. So what we can do is simply rewrite this and set this to 0. Because again, we've got to find these roots. All right. So the first thing that we need to do, always make sure you set it to 0. Great. First thing that we need to do is evaluate this. Are there any greatest common factors? I noticed that we've got x to the second, we've got an x, but we don't have a variable in the third term, so that won't work. But what about 3, 6, and 24? Yeah, we can factor out 3, so let's do that. We're going to factor out 3 from each of these terms, so it's going to leave us with x squared in the first term. 3 times what gives us 6x? Simply 2x. And then 3 times what gives us negative 24? Negative 8, right? Beautiful. And make sure again that we're keeping this equal to 0. And so, like before, we need to figure out which two numbers multiply to give us negative 8, but add to give us positive 2. So what are those numbers? I know that 8 and 1 are a pair, right? And 2 and 4, and do either of these combinations give us positive 2? Yeah, I think 2 and 4. But again, this is a negative number, right? So one of these are going to have to be negative. And because this is positive, it's got to be the greatest number. So this has got to be a positive 4, and 2 has got to be negative. Great. So we're going to rewrite this like 3 open parentheses. And because this is x squared, we know it's going to always be x times x. So we've got x minus 2, and then we've got x plus 4. Great. Equals to 0. Almost done. We have not found our roots yet. What we need to do is we've got to make x minus 2 equal to 0 and x plus 4 equal to 0. And when we do that, x minus 2 equals 0. We're going to add 2 to both sides so that x equals positive 2. We've just found our first root. Amazing. Let's do the right term. All right, so we got x plus 4 equals 0. Let's subtract 4 from both sides. And x equals negative 4. Beautiful. We just found our second root. So this, ladies and gentlemen, is our answer. For question 7, we're going to be solving by factoring, but this one's a little bit tricky because we taught you two methods of this in class. We taught you the grouping method, and we also taught you this number sense method, which some students have a preference for, others say is a little bit tricky. I'm going to review both. I'm going to start with grouping, and I've actually got a slight preference for this grouping method. So let's jump right on in. Again, we're going to be solving. We've got to find the roots. I know that because this is equal to 0. How do we start? We're going to be multiplying the first term by the third term, or the last term. 6 times 2 is going to give us 12, and we need to figure out which two multiples of 12, or which two pairs of numbers that multiply to 12 give us positive 7. So let's sort of go through that right now. I know that 1 times 12 multiplies to 12, as does 2 and 6, and 3 and 4. When we're looking at this, do any of these pairs of numbers add to 7? Clearly not 1 and 12, or 2 and 6. 2 and 6. We're going to go with 3 and 4. Because 7 is positive, both of these have got to be positive. And because 2 is positive, we're going to make this a positive 3 and a positive 4. Great. Beautiful. So let's rewrite this like 6x squared plus 3x plus 4x plus 2 equals 0. So we're going to be grouping. How exactly do we approach this? Well, when we look at this, these first two terms, 6x squared and 3x, can we pull anything out of these? Is there anything that we can factor? Sure is. We are going to factor 3x from both. And what does that leave us with? That leaves us with, what, 3? Actually, let's write this like this. 3x times what gives us 6x squared? Simply 2x. And 3x times what gives us 3x? Just 1, which is how we got this. Again, 3x times what gives us 3x? 1. Beautiful. So likewise, we're going to be factoring something out of 4x and 2. What do they have in common? 2. We can pull that out from both. So I'm going to pull out just the 2, and that leaves us with what? 2 times what gives us 4x? 2 times 2x gives us 4x. Beautiful. And 2 times what gives us 2? Simply 1. Beautiful. And we're going to make this equal to 0. And again, this is a positive 2. So wait a second. I see something in common here. Here we've got a 2x plus 1, and we've got a 2x plus 1. We can actually factor that together. So we're going to rewrite that like 2x plus 1. And then we can consolidate sort of the 3x and the 2. We can factor these together. So we've got 3x plus 2 And again, this is all equal to 0. Beautiful, and we're getting super close. What are the roots? So I'm going to rewrite this like 2x plus 1 equals 0. We've got to subtract 1 from both sides, and when we do, we've got 2x equals negative 1. And then that's going to give us, when we divide 2 from both sides, that's going to give us x equals negative 1. I'll write that for you guys. X equals 1 over 2. Beautiful. So that's our first root, x equals negative 1 over 2. Let's take a look at the second root. I can see that it's 3x plus 2 equals 0. Let's subtract 2 from both sides. We've got 3x equals negative 2. We've got, again, of course, subtract 3 from both sides. And x equals negative 2 over 3. We've got our second set of roots. Beautiful. Negative 1/2 and negative 2/3. That, ladies and gentlemen, is our answer. We just factored that. That was a lot of work, but that was actually kind of fun. Now let's jump into the sort of number sense method. So now let's factor using this number sense method. We're looking at 6x squared plus 7x plus 2 equals 0. We've got to find the roots. And because we're factoring, I know that we're always going to set this up with two sets of parentheses equal to 0. And I also know that because this is x to the second, and when we FOIL, it's always going to be x times x to give us x to the second. So it's going to be something x times something x. The real big question mark right here is what precedes it? What is this coefficient? And when we're looking at 6, what two numbers multiply to give us 6? Well, in this case, it could either be 6 and 1 or 2 and 3. So what I'm going to do is I'm going to try a 2 and a 3. And so what I know is that 2x times 3x is going to give us 6x. Now what we need to figure out is what two numbers are we also going to include that when multiplied will result in positive 2. And then when we multiply like this, we'll add to give us positive 7. So let's think about that. We're going to actually jiggle some numbers real quick. So I know that if we're looking for numbers that multiply to give us positive 2, what could that be? That could be a 1 and a 2. So let's actually try a 1 here and a 2 here. So we're going to be doing a little bit of experimenting. 2 times 3x, 2x times 3x is 6x squared. Beautiful, we're great. 2x times 1 is going to give us 2x. Okay, that's good. 2x times 3x is going to give us 6x. But we just said this is 2x, right? 2 plus 6 is 8, so that won't work. But 2 times 1 will give us 2, so that does work. But I'm not thrilled with that right there. So let me erase this a little bit. Okay, so we're going to get rid of that 2, and we're actually going to swap it. So here instead we'll pop in this 2 here, and here we'll in the first term we'll pop in the 1. So now let's multiply. 2x times 2 is going to give us what? 4x. And 1 times 3 is going to give us 3x. And I know that when we add these this pair of numbers, 3x plus 4x, that does give us 6x. And so again, this has got to be then positive. And we just figured it out. And so again, if we FOIL this, right, 2x times 3x is going to give us 6x squared. 2x times 2 is going to give us 4x. Here we've got the inners. 1 times 3x is going to give us plus 3x. And then finally, 1 times positive 2 is going to give us positive 2. And we simplify. That gives us this right here. So we just simplified it right here using our number sense method. But again, we're not done. We've got to figure out what the roots are. We've got to solve for x essentially. And we did that just a second ago. And we know that when we solve for x, it's going to be negative 1/2 and negative 2/3 using this sort of alternative method. So we've got two options to choose from, and I know this isn't easy, but this is actually kind of fun, right? I think it's pretty exciting.